Yes, it works. Okay. So the first question, anyone have questions or issues about that? I wanted to know your name, your major. What was your favorite color?
What is your favorite color?
And have you taken calculus before? If so, where? When? High school in 1997?
I will not make age an issue of this campaign. I am not going to exploit, for political purposes, my opponent's youth and inexperience.
Okay. So on the figure above, sketch the graph of a function y equals f of x that satisfies the following conditions. F of 0 equals 1. So what I want to do, how I do them, is I make notes for myself on the bottom here if there's something special. So for these right here, I just graph the points. So f of 0 equals 1. I'm going to come over here to 0. I'm going to put a dot here at 1. Next one, f of negative 4 equals 2. I'm going to come over here to x equals negative 4, y equals negative 2. I'm going to put a little dot right there. F is defined everywhere. Okay, I'm just going to leave that. That means I have to have it for any x. I have to have the answer what is y. For every x greater than 0, f of x equals negative 2. Okay, so that means that for any x greater than 0, y equals negative 2. And then I want f to be increasing on the interval negative 6, 0. So what I'm going to do is I'm going to come down here. I'm going to make a little note. Yes. So, and this should be a hard note. And I'm going to say this is increasing. Now, when I go back to fill out my conditions, when I'm done listing my conditions, there's actually only one here that's kind of mysterious. That's this one. I'm going to use this as a guide. Okay, so I need it to be increasing from here to here. So that means that negative 6 needs to be less than this point, some point over here. I'm just going to draw. And now I need it defined everywhere. That means I need a tail on this. I'll just do that. And now I'll go through my conditions again to check. So f of 0 equals 1. That is true. F of negative 4 equals negative 2. That is true. F is defined everywhere. That is true. For every x greater than 0, f of x equals negative 2. That is true. F of x is increasing from negative 6 to 0. Here's negative 6. There's 0. That is true. And now I'm going to check my vertical line test. So to check my vertical line test, I'm going to take my ruler. And I'm just going to slide it across here. Is it the case that I only have one y for every single x value? Yes. I'm not violating the vertical line test. So this is correct. How do we feel about that? 1 to 5. Let's see. How do I do this again? Oh, it's on this other screen. Let's see. Sure, this is very slow. And why won't it let you use the last one? That's annoying. Okay, so how do we feel about that question, 1 to 5? And are there any questions about that? Feel free to ask all sorts of questions. Do we have any questions? No. So someone asked in chat, for the left tail, does it matter if it was pointing up or down since it wasn't specified? No, it doesn't matter. You could have it go up you could have it go this way up here. You could have had it go this way. You could have had it you could have had it done squiggly. This was a fair answer. Now, let me make sure I didn't violate my vertical line test there. This is a fair answer. You could have had it do that. You could have had it do whatever you want. It's your function, as long as it meets the condition. Okay, so this last condition, there's a little confused how about I graphed the last condition. What I did was I made some notes at the bottom here. Okay? And then what I did is I started here and I went up and up and up and I went there. Okay? Are there any questions about that? And if that makes you uncomfortable, by all means, come see me during office hours. We'll make this work for you, because this is going to be, you can't see me point at this at all, and yet I'm pointing to it like you can. If you're having trouble with this at all, by all means, come see me during office hours, because this is going to be a major kind of skill for this class that you need down. And we'll do it, and if you have issues with it, I'll be happy to work with you in office hours. I'll give you exercises that you can go work with the ASC tutors on. I want you to get this skill because it's actually really important for this class. There's also a question, how can I do the attendance? Well, actually, that's simple. I can export all of the data, like when you're responding to polls, and then the fact that you're in there. I can do all of that, which is kind of cool on this. I don't have to read the attendance section. I can just look at the attendance straight. Yes, you will be able to retake this quiz. I haven't gotten that system working yet. There should be a quiz retake up, though, this week. And that's true for every quiz. So the first quiz you can retake for full credit. After the first quiz, you can retake quizzes for half the points you missed. And as soon as we get the system going, I'll make an announcement about that. All right. Any other? Oh, and then why did I do this? Why is there? So this circle here is because I already have a point for 0. And I can't like draw something down here. That would be a no-no. Okay, because that would violate the vertical line test. So what I need to do is I need to do a piecewise function. And you can actually see these in your book. If you go into the book in section 1.1, you'll actually see a bunch of piecewise functions. Okay. Yes, so you could, are there notes that you can look at before taking the quiz with example problems? Yes. If you look at the notes online, let me see if I can do this. So if you go to Files on Canvas, you can actually see there's a couple things you can see in here. You can see the class notes. And if you look on pages, class notes, suggested problems, and you come up here to week class 1A, you'll actually see the whole section, the whole set of notes on functions and sets. And then if you looked here, you actually saw there was stuff from pre-calc that I put in here. That was stuff like introducing function and graphing functions. So if you're having trouble with this, you can actually look at this activity here, and this will help you with some of this material. And then there are a bunch of web assigns that if you go in the review, and they're completely extra credit, and I'll talk about how WebAssign extra credit works later, but there are extra credits that go over the stuff that you were supposed to learn in pre-calc. Now, for some of you, pre-calc was a while ago. For some of you, it was your first online class experience over the summer. So there are extra things. Aside from the quizzes in the beginning, is the info for the Monday, Wednesday lectures the same or different? It's exactly the same because what we're doing is group projects. So if you come on Monday, you'll split up into groups. We'll work on the problem sets. If you come into Wednesday, you'll split into groups and you'll work on problem sets. You're welcome to come to both if you want to. We'll be working on the exact same problem set. So that should answer that question. Any other questions? We'll talk about that later. So some people are concerned about their ability to do this stuff, and that's okay. We will talk about it in office hours. Come see me if you're nervous about this. All right. Okay, let's move on here. This is another one of those things that you should have remembered from pre-calc, although it's a little bit different in the way it's presented. So here's the function I want to play with. F of x equals 4 if x equals 0, and 1 over x if x does not equal 0. Evaluate f of 1. Well, I've got f of 1 equals 1 over 1 equals 1. I plug in 0 to this formula, and I get 4. Because if I plug in 0 here, I go, oh, x is 0, so I go 4. Here, however, I plug in 1, I get 1 over 1, because x does not equal 0. So if x does not equal 0, I use this formula. So I use the top one if I've got, let me see if this thing works. Hey, it does. I've got the top one if x equals 0, and the bottom one if x does not equal 0. So here I plug in 1 over 100. Well, 1 over 100 is not 0. So I'm going to be using this top formula. I'm sorry, the bottom one. And I get 1 over 1 over 100. Well, if we remember how to divide fractions, this is 1 divided by 1 over 100, which is multiplied by the reciprocal, you get 100. For part D, t does not equal 0. So I'm going to take t, I'm going to put it in our formula. T is not 0. I'm going to get 1 over t. All right, how do we feel about those first 4 there, 1 to 5? Let's see. Polling. Multiple choice. A through D on question 3. This is incredibly slow. What's more, you can't, on Teams, you can actually do the polls in advance. But on this system, you can't. You have to do the polls like, it's a frustrating thing. So 1 to 5, how do we feel about that? I have some non-voters here. I want you to vote. Unlike the presidential election, your vote actually counts in this class. If I get a lot of 1s, I will actually, go back and, say things and, change the way the course works. I want you guys to understand. Your vote counts. Your vote matters. Your vote is how I take attendance. Nope. The 7 people that, the 7 people that are not responding are apparently not responding. All right. Okay. I will get to the range in a moment. The domain. The domain is all real numbers. You could say it in interval notation, which is probably how most of you said it. You could say it using this funky little R if you feel like it. That means all real numbers. That's a set of all real numbers. All of those are valid options for that. Part F is probably the one that was confusing. What I wanted you to do was I wanted you to Google this word. Image. Okay? And that was kind of the idea. So the idea of this first question, and remember, you can retake this quiz for full points. So I feel justified pulling this trick on you at the beginning because I'm going to let you retake it for full points. Now, this word image. What happens when I Google the word image in mathematics? Okay? Let's go to the second screen here and let's Google the old thing. Now, I come right here, it says image, mathematics. Hey, it's the image is the set of all output the image of A. So given a subset of A of its domain, it produces this. So it's kind of like a range, except it means that if I've got a set here, if I have a set, that means the output I actually reach if I restrict my domain to that set. And, there were videos and stuff too that would actually make this here, pre-image of a set, image of a set. Some of it might have been a little confusing, but I kind of wanted to test your ability to kind of use the internet to wade through the dross and and try to figure out exactly what you were looking for. So you could use that. You could also just, see here, what I was looking for was the outputs associated with the inputs 0, 1. And you can't see me at all because I'm on the wrong screen. So what I did here was I made an arrow diagram. This is called an arrow diagram. And yes, the answers to the quiz will be posted. This is called an arrow diagram, which, kind of makes the retakes kind of easy. You have to take the retakes closed book, but you could see the answers before you take the retake. Yeah. But not if you're doing a makeup and not a retake. I'm actually going to, insist that you not look at the answers before you do that. And you'll have to cite an honor code statement about that. And I'll get to that. So what I did was I went from 0, open 0 to 1. So this is the X space up here. This is the A. This is my A. Open interval 0, closed interval 1. Now, if I take 1 as my point in my Y space, where does 1 map to? So if my input value is 1, what is my output? 1. So I drew an arrow from 1 to 1. Now, as my input gets closer and closer to 0, what happens to my output? Yeah, it gets larger. In fact, what happens to it is that it goes off to positive infinity. So if I go on Desmos and I graph this function, whatever x, because remember, I don't need to worry about 0 because 0 is 4, but I don't care, right? There's a point right here at 0, 4, but I don't care about what's going on. I don't care about what's going on from 0 to negative infinity. I only care about what's going on here. So if I look, as I get closer and closer to 0 in the X space, I blow up in the Y space. I go to an infinity. And that's actually easier to see if I do one of these little arrow diagrams. So if I go back with the arrow diagram, as I get closer and closer to 0, these arrows, right? If I put in 2 here, if I put in 1/2, that's going to map to 2, correct? If I put in 1/4, that maps up here to 4. If I put in 1/8, that maps up there to 8, and it goes on and on to infinity. So my output, my image of A is 0. I'm sorry, not 0, 1. Is 1 infinity. It's everything starting from 1 and going off to infinity. How do we feel about that? 1 to 5. Now that I've explained what's going on there, how do we feel about that? So let's see. Is there a faster way to do this? There is no fast way to do this, is there? I need to write like a macro or something. So 1 to 5, how do we feel about this now? Okay. A good kind of curve. All right. Okay. Yes, that's still based on that 1 over x function. So as I said before on the thing, all problems on this page refer to this particular problem function. Okay. B was 100. F of 1 over 100 equals 1 over 1 over 100 equals 1 divided by 1 over 100 multiplied by the reciprocal, and I get 100. And that's how you know it's like, it's heading off there. Oh, B was this output. So if the inputs are restricted to 0, 1, B, capital B is the output. Okay. And there are a couple things that are being kind of jolted in there. Okay, I'm going to look at the questions here so I can answer. Yes, I mentioned the quiz. Is this still based on that? Yes. So the Blackboard meeting on Wednesday is going to be the same as today after the quiz. So we'll be going over the quiz to, 1B instead of 1A. And I haven't posted 1B yet, but I will probably this evening. All right. So let's go over this last one. So what I want to do using this function, notice that nothing here is 0. So using this function, what I'm going to do is I'm going to plug in 1 over x for f. So this is 1 over x plus h minus 1 over x, all over h. Okay. All I'm doing is plugging in what x plus h is, f of x plus h is, and f of x. So how do we feel about that? 1 to 5. Do this again. Multiple choice. Add. 1, 2, 3, 4, 5. Part G. So I could have, and then if I wanted to simplify, I could, and I'll get more into simplification in the next class. But I didn't make it so you simplify. So no, you do not need to simplify further. If you did wanted to simplify further, this is what it would look like. It'd be x over, what I do is I take a common denominator. And then I would split this off. I would distribute this negative. So this is really negative x minus h. The x and the negative x would cancel. I'd wind up with a negative h on the top. And then the h, this stays. I'd move both of these down. Oops, there should be another x in here. Sorry about that. I'd move both of those down. And then the negative h and the h cancel here. They become 1. So I wind up with a negative 1 times x plus h times x. Yes, was that my only mistake? Yeah, that was it. So that's the simplification. You didn't need to do that. The thing that I wanted, though, was this right here. Oops. The thing I wanted was this right here. Any questions, comments, issues, suggestions, thoughts? Okay. All right. So that's how quizzes work. I know there's some questions in here that I haven't answered. Do you get credit if you simplify? No. But you lose credit if you simplify wrong, like I did, right? I forgot the x on the bottom. I would have lost a point or half a point. So the point is, don't oversimplify. Keep it, and I'll get into more of that and why that's important in the next one. It's not just so you don't make mistakes. There's actually a reason we don't want you to oversimplify. And I will get into that on the next time. How do you know when to simplify? The answer is when you have to. So the how do I say that? I'll show you a lot what I mean about that next time. But if the thing says simplify, then do it. If the thing does not say simplify, don't. How do you know when to stop? Well, in our class, it's mostly going to be when the calculus is done. So when the calculus is finished, we want you to stop. And I'll get into that next class. So for the moment, it's just a little mystery that's going to make you feel a little uncomfortable. Will you always get to see the quiz before you take it? Absolutely, yes. That's part of the thing. I want you to work out. The quizzes are really homework that's written, because the homework on WebAssign, which is awesome, but you don't get any experience writing. So this is more like homework, but I want you to take it closed book. And yes, you are submitting notes, but remember the notes are about the stuff that gets posted on YouTube, the lectures, not these things. Are there any other questions? Okay. So do I send reminders? The lectures are on Twitch first. I record them on Twitch, and then I post it on the thing. Okay, why is there an H on the bottom? Well, there was an H here. So I'm just subbing in. So f of x plus h is 1, because nothing's 0. If I plug it into my formula, that is simply 1 over x plus h. F of x is simply 1 over x. So when I sub it all in, I get 1 over x plus h minus 1 over x over the h.